Welcome to this video tutorial involving writing a graph first in our standard form of an equation, rectangular form, then converting it into parametric form. So first thing is we need the equation of this line. We'll begin by finding its slope. The slope is going to be equal to negative 6 minus 6 all over 2 minus a negative 1, which is negative 12 over 3 or negative 4. So now we've got that the slope is negative 4. We could take either point. I'll take negative 1 comma 6. And we could just plug into the point slope form from before. Y minus y1 equals m times x minus x1. Plugging it in, we would have y minus 6 equals a negative 4 times x plus 1. And solving, we'll have y minus 6 equals negative 4x minus 4, which means y is equal to a negative 4x plus 2. That would be the equation of this line in rectangular form, which is our typical way of writing it. However, we want parametric equations that work for the line segment. Now, perhaps the easiest way to write parametric equations is to do something like this, where we say x of t is equal to t, and y of t would just be equal to negative 4t plus 2, because then everything works. However, we need this graph to draw from the right to the left, which means we have to make the x of t negative so that it does draw from right to left. Now, in doing that, we would need to get rid of this negative sign, because now when we plug in, we would have that y of t, when we make this substitution, is equal to a negative 4t plus 2. Since this is a line segment, we also need to stipulate the domain for t. So t would actually start at negative 2, because the opposite of negative 2 is a positive 2, and it would go to positive 1, because the opposite of 1 is negative 1. This would be one set of parametric equations that would work. However, we could come up with an infinite number of parametric equations that would work as well. So let's say that we went with x of t is equal to a negative 4t. Then in this case, y of t would be equal to just t plus 2. Because what you're thinking in this case is, oh, well then this means that x divided by a negative 4 would be equal to t. So one other equation that we could have, keeping in mind there are an infinite number of them, would be that x of t could be equal to, let's say, negative t over 4. Now if we did that, then this means that 4x, actually a negative 4x would be equal to t, and then y just needs to be t plus 2, so we could have y of t is equal to t plus 2. Again, it's kind of a way where you solve for t and then figure out what y would have to be with the condition. Now, since we need to start at an x value of 2, in this scenario, to start in an x value of 2, t would have to be equal to a negative 8. That would get us positive 2. And to stop at negative 1, we would need t being equal to 4. So this would be a second potential set of parametric equations for the graph that we desire. Let's just do one more set of parametric equations for this same graph. So let's go with x of t being equal to, let's just go with 10t, but make it negative because the graph has to draw from the right to the left. Well, now over on the side here, I'm just going to say x divided by a negative 10 is equal to t. If we want negative 4x to be the case, then y of t, now think about it for a second. What am I going to attach to t here, keeping in mind that t is really x over negative 10, so that it turns out to be negative 4x. If I want to get a negative 4, I need to multiply here by 40, which means that this is going to be a 40t. And then we'll keep the plus 2 along for the ride. Now as we go to think about the boundaries, we wanted x to start at at positive 2. For x to start at positive 2, t would have to be a negative 1/5. And then we wanted x to end at negative 1. For it to end at negative 1, t would have to be 1/10. So there would be yet another set of parametric equations that could do the trick. Ultimately, it's probably best to start with the most straightforward of the group, and then you do have to kind of think about converting between both rectangular and parametric as you manipulate those equations to get different forms that would work. So, as we're done with this would be a set of parametric equations that would be legitimate, any of the three. One last comment is, how can you be 100% sure? Well, let's say I took a negative 4x right here. That would be multiplying this by negative 4. That gets me the t. If I were multiplying this one over here by negative 4, multiplying both sides by negative 4, we would have 40t, which is exactly what we have right there. It's one last check that you can do to make sure that your equation matches up. Here we're saying for y, you take negative 4 times your x and then add 2, and that works for each of these. If we took negative 4 times our x and then added 2, we would be getting our y equation on each.